This is Coyote with the Azure Monitor team. In this video tutorial, I'll walk you through the process of configuring Autoscale to change the number of virtual machines in a scale set based on user-defined performance criteria. Autoscale enables you to provision just the right amount of resources to support the load on your application. The amount of resources can be quickly increased during periods of high load, such as flash sales and seasonal workloads in customer-facing applications. On the other end of the spectrum, resources can be reduced during periods of low loads, such as nights and weekends for corporate apps. Autoscale may be applied to several resources in Azure, including virtual machine scale sets, app service web apps, and API management services. By navigating to Azure Monitor and then to Autoscale, I can view all the resources for which Autoscale is applicable, along with their current Autoscale status. The major benefit of Autoscale is that it allows you to dynamically increase or decrease the available resources that will be consumed by and billed to a subscription depending on the load on the system. Another entry point for configuring Autoscale is to start in the resource blade, which is what I'll do in this case. I'll start by looking at my resource group that contains a VM scale set made up of 3 virtual machines and a load balancer that distributes traffic across them. In this example, if there's very little user traffic or low load on my app, I may be running 3 VMs in a case that can be easily supported by a single one. And on the other extreme, if there's an unexpected increase in the number of concurrent users or a spike in load, an admin would typically have to manually respond to allocate more resources on the fly. Instead, Autoscale can be used here to scale in and scale out the number of available VMs based on user-defined performance metrics or predetermined time intervals. Now I'll go ahead and configure the Autoscale condition on the VM scale set to reduce the number of VMs to as few as only 1 or to as many as 5 VMs depending on the number of connection requests received at the load balancer. First, I'll start by editing the default condition. I'll set the default, maximum, and minimum VM instances to 3, 5, and 1 respectively. Next, I'll add an Autoscale rule to scale out by 1 instance when the load balancer receives more than 50 SINs. SINs here refer to the number of TCP connection requests from the client side. Because I'd like the total number of SINs during a given time period, I'll choose sum as my aggregation. I'm setting this rule to an artificially low threshold of 50 SINs, so it can be breached quickly in this demo environment. And it's always best practice to create a matching rule to scale in when the Autoscale created resources are no longer required. I'll do so now and add a rule to scale in by 1 instance when the number of connection requests drop to 50 or below. Note here that I could have easily selected other options from a range of available metrics to define my Autoscale condition. For example, CPU usage on the VMs or the number of HTTP requests in an application gateway would also be good candidates for this scenario. Once the Autoscale condition is set up, I can view the history of its actions directly in the scaling blade by selecting the Run History tab. Here you can see that there were 2 spikes in connection requests, one at 7 p.m. and another at 8. The Autoscale rule successfully provisioned additional VMs to accommodate these spikes, initially by scaling out from 1 to 2 VM instances before scaling back into 1, and then scaling out to 4 instances during our busiest period. Autoscale operations are also visible as events in the activity log. Finally, in this demonstration, I've only configured Autoscale via the portal to explain the concept. However, Autoscale can be deployed and managed with automation, using Resource Manager templates, PowerShell, and Azure CLI. Thanks for watching this short tutorial. Remember, you can take advantage of Autoscale to improve efficiency as well as reduce the consumption cost of Azure compute resources.